Dear student, due to coronavirus, school started online classes for your study. So you can subscribe Golden Flower Palia YouTube channel, like and press the bell icon.
Hello students, good morning to all. Now the topic of the day is compressibility. We have taken class 9 chemistry and the subtopic is compressibility and the name of chapter matter in our surroundings. Before starting this part, we have already explained about solid, about liquid, about gases and their properties. So student, as you know very well, solid, these are the rigid in nature. Liquid, these are not in rigid nature. Gases, these are not in rigid nature. So before it, I was giving to you about rigidity and about fluidity. One more characteristic feature is compressibility. So now question arises here, how we can show that solids and liquids does not compress. What gases they have high compressibility, means they are compressible. So here to show gases are compressible in nature. So for that we have taken here 3 syringes of 100 ml, means this syringe having capacity of 100 ml of each. 3 syringes of 100 ml each. Now each syringe inserted into a rubber cork, so there will be no leakage of air and liquid part. Means we can insert the nozzle of the syringe into a cork, a rubber cork. Now next we can remove the piston of each syringe. After removing the piston, in first syringe we can fill common salt. This is a solid. Now in second we can fill liquid, water, and in third syringe we cannot fill anything because already air inside syringe is present. Now we can put piston of this air syringe. So whenever we take piston, on applying Vaseline and kept the piston on the syringe, so there is no movement. On second, where liquid is there, water is there, we apply same thing, means on applying Vaseline we insert or cap the piston on the syringe. Now third one, where air, gas is there, so on applying the Vaseline we can insert the piston. So what will happen? Now conclusion, whenever weight about 50 gram weight we can apply on this syringe 1, now on syringe 2, now on syringe 3. See where gas is there. So we have seen where gas is there, the piston move down, piston moves down and air will be compressed, means here compressed air will be formed. So by this experiment, means we can show that solids and liquids, they doesn't compress. What gases, they have more and more compressible in nature. That is why CNG, compressed natural gas, and LPG, liquefied petroleum gas, both gases in a compressed form will be converted into liquids. Whenever we insert a nail on a nozzle of gas cylinder, so gas released from to the pressure, means gas released from cylinder. So this is about compressibility of gases. Now student, second portion of this chapter, this is a diffusion. Question arise here, what is a diffusion and how it can proceed. So student, diffusion, the spreading out, means spread out and mixing of substance with another substance, means mixing of one substance to another substance due to the motion of its particle. Or this diffusion may be defined again, the movement of molecules of gases, solid and liquids from its higher concentration to the lower concentration. Means the movement of molecules or particles of gases, liquid and solid from its higher concentration to the its lower concentration. So this is known as diffusion. Spreading out, this is also diffusion. So for example, we have taken two gas jars. One gas jar, we will fill bromine vapors, means this is a bromine gas, Br2, and it is a red brown in color. And another gas jar, we can invert it on it. So this is having only air and this is a colorless. After some time, the bromine molecules, they move on up and up, means movement of particles move from one gas jar to another gas jar, and both the gas jar becomes red brown in color. So this is a mixing or this is a spreading out of substance, means one substance is spread out into another substance to form uniform mixing, means uniformity. Now second thing is there, how is this diffusion carried out? So gases having more diffusion capacity, then liquids, and finally then solids. So this is about rate of diffusion, means what kind of factors that affect the rate of diffusion in container. Now class, diffusion in gases, diffusion in liquids and diffusion in solids. So as you know very well, the gases are diffused fastly, then liquids and then solids. So light gases means we're having light in weight, diffuse faster than heavy gas. Suppose that we have taken two gas, one is a light gas like hydrogen and one is a heavy gas. So light gas diffuse fastly due to high kinetic energy of the molecules or particles. They move randomly and faster. For example, a smell of food, they came out from the kitchen and is spread out in a whole room. So this is a phenomenon of diffusion in gases. Second is the smell of perfumes. Suppose that we have spread some perfume in the corner of the room. After some time, the molecules, the particles of perfume, they move and spread out this whole room. Another one, whenever we take agarbatti or dhupbatti, this is an incense stick. So the smell of dhupbatti or agarbatti, after some time, they spread whole of the room. Next, if sometime LPG cylinder is leaked, then we feel the leaking of LPG cylinder because their particles or their molecules, they spread in a whole room or in a spread in all randomly in the motion. So these are the example of about diffusion in gases. One thing kept in mind, diffusion in gases is very fast than the liquids and then the solids. Now second one we have taken here, diffusion in liquids. So diffusion in liquids slower than that in gases. For example, we have taken potassium permanganate. Potassium permanganate. This is a purple in color and kept in a beaker, though filled with water. So initially the particles of potassium permanganate, they move in a very slow, but after some time the purple solution of KMnO4 is formed. So this is a phenomenon that occurs in liquid, diffusion in liquid. Another one, copper sulfate. Copper sulfate. This is a blue in color and this is a purple in color. So this blue colored copper sulfate, whenever we have taken in a beaker and poured water, so after some time the molecules of copper sulfate, they spread into a water. So blue colored solution formed. So this is a phenomena of diffusion in liquids. Now third one, diffusion in solids. Diffusion in solid is a very slow process. It doesn't take in second or minute, in hours. Takes days and months, years. So for example, if we have right here on the board A and make a circle, means we have write capital letter A and make a circle. After 15 to 20 days back, whenever we want to rub it It is not easy to rub it because the particle of chalk and the particle of this board they intermix together. One in little extent. Similarly, suppose that we have taken two metal block and kept tightly like that, tightly packed. And after few years back, if we want to separate it, they separated what take more and more force because one metal particles can mix with another particle metal. So this is about diffusion in gases, diffusion in liquids and diffusion in solids. Now factors affecting the rate of diffusion means what kind of factors they affect the rate of diffusion. So we have select two. One is the temperature and another is the density. So first one, temperature. The rate of diffusion increases with increasing temperature. Means this is the rate of diffusion is directly proportional to temperature. Now student, the rate of diffusion is directly proportional to the temperature. As we increase the temperature, the rate of diffusion increases. Why? Because the molecules getting energy and they move faster and faster while taking kinetic energy. That is why on increasing the temperature, the molecule of gas, liquid or in solid, they move faster. Second is density. The rate of diffusion is inversely proportional to the density, means proportional to the density. So student, if particle is lighter in nature, means having lower density, diffuses faster than the particles having heavy in nature. Heavy, less diffusion means the rate of diffusion is very low. So this is about diffusion and its factors. In next proceeding, I'll explain another phenomena. For that, this is a for you. Thanks.
Do self study at home and stay home, save lives. Thank you very much.